Well, we do want to understand power functions so we can understand the mathematics of this thing, okay? So this is something that might be a little fuzzy, you know, because when I asked for power functions, a lot of times I got exponentials. First one I got was an exponential, like a to the x, that's exponential. And then people started giving me power functions. Okay, so you got to understand power functions and the way they behave. If p, okay, a power function is like an x to the p, right? So that's a general form of the power function, even though I got an x to the negative p written down here. We'll see why. Okay, well, if p is positive, then, well, if p is 1, then you have like y equals x. That's just a straight line graph, right? Okay. If p is positive but greater than 1, like 2, you have like a parabolic graph, okay, increasing concave up. If p is like 1/2, it's like increasing concave down, right? So we have to have that scheme. We have to understand those functions. We can't use them if we don't understand their classifications. And you've dealt with them in calculus. You really have to conceptualize this family of functions, okay? Which should be done in pre-calculus. And it's very hard to get that done in pre-calculus because our educational system doesn't support that kind of thinking. Okay. For negative powers, what happens? If you have a negative power, x to the negative p is like 1 divided by x to the p. So x can't be 0. You're going to have a vertical asymptote at x equals 0, and I'm not going to reteach you pre-calculus and calculus, okay? But you're going to end up with graphs that have this shape. For even powers, you know, the graph is like this on both sides, but that doesn't matter for what we're doing. For graphing force versus separation, separation won't go less than 0. Okay, and we can't allow it to be 0 if we have an inverse power, right? So the domain is just, you know, for x greater than 0. You got to think in terms of domain and range. Right now I'm trying to teach my pre-calculus students to think about domain and range. That's a real stretch. Okay? Okay. Which is why it doesn't get done in pre-calculus and people still come out not thinking in terms of domain and range. Okay? You need to be sure you do that. And you did that in calculus, but you really want to think even more. Okay, well anyhow, okay, you've got this graph here, right? And it will have an asymptote at the x-axis and an asymptote at the y-axis. Now, if it's an even negative power, if the domain wasn't restricted, you'd have like this and this, right? Even positive powers would be like this and this, okay? But for even fractional powers, unless you have fractions with odd denominators, you don't even have anything over here. It's only defined for positive values. So you need to understand those things about power functions to put this in context. Okay? So, for the magnet, as I said, it's like you have a different power function at every point, a continuously changing power function is one way to model it. Okay, for a real world magnet, for the magnets that we use. And we aren't going to do that. Okay, well, let's think about what happens then for inverse square forces. What do you think the function would be if you had an inverse square force?